Hello students, in today's lecture we are going to learn about systems of particles and rotational motion, NCERT section 6.7.2 and example 6.5, 6.6. This is disclaimer. Learning objective. By the end of this lecture you will able to understand the concept of angular momentum for a system of particles, torque for a system of particles, relationship between torque and angular momentum, and conservation of angular momentum. All right. So in today's lecture, we will cover first 6.7.2 torque and angular momentum for a system of particles, not for a single particle, for a system of particles. Then conservation of angular momentum. Then example 6.5, and last we will see example 6.6. So these are the today's lecture topic. So, angular momentum of a single particle. So we know the angular momentum of a particle is denoted by small n, whereas the linear momentum of a particle denoted as small p. So angular momentum of a particle with linear momentum at a position r relative to an origin O, we can denote mathematically as L equal to r cross p. Here angular momentum shows the how fast is it rotating. Alright. So the mathematical term is L is equal to r cross p. Angular momentum for a system of particles. Here we will see angular momentum for a system, not a single particle. Let's see. Here we have a rigid body and that rotating around a fixed axis, as shown in figure 6.16. Here the fixed axis is z axis. So we have a rigid body and rigid body rotating around this fixed axis, and we have a system of n particles. So every particle, as shown in figure 6.16, every particles move in a circle like this, move in a circle which lies in the plane perpendicular to axis and has its center on the axis. So here a system of n particles moves from point P to point P prime, not a single particle. Every particle moves a circular path around a fixed axis. Next, uh, total angular momentum, capital L, of a system of particles about a given point is a vector sum of the angular momenta of individual particles. And this is a very important concept. We know angular momentum for a single particle, that is L is equal to r cross p. Yes or no? Where p is the linear momentum, the formula is mass into velocity. If we talk about the angular momentum, so L is equal to r cross p. All right. Now here we talk about the for a single particles, for a not a single particle. Here we talk about the for a system of particles. Now for a system of particles, we considering here all particles and their angular momentum. So if I have n particles, so vector sum of angular momentum of individual particle. So for first particle it will be L1. For second particle it will be L2. Similarly for n particle it will be Ln, and we add via vector sum. So for a system of n particles, the total angular momentum capital L is L is equal to L1 plus L2 plus Ln. Now the important point here is this small L1, small L2 and small Ln shows the sum of vector sum of angular momenta of individual particles. For first particle, this one for second particle, this one for nth particle. And in the summation form, it will be total angular momentum capital L is equal to I equal to 1 to n Li. Now if we put the value of I is equal to 1, I equal to 2 and I equal to 3. So it will be like again form like this. Li is the angular momentum of the ith particle. Alright, this is the vector sum of angular momenta of the individual particle. So remember this. Angular momentum for a system of particles. Now, uh, suppose we have a ith particle. So in that case, their angular momentum, it will be Li is equal to Ri cross Pi. Now, suppose you want to calculate the angular momentum of the second particle. So I equal to what? It will be 2. So L2 is equal to R2 cross P2. Alright, Ri is the position vector and Pi is the linear momentum of the ith particle. Therefore, the total angular momentum capital L of a system of n particles is this one. L is equal to summation I equal to 1 to n Li. Now we know L is the angular momentum for a single particle. For suppose for a ith particle, not a single particle. For ith particle, the angular momentum is Ri cross Pi. Yes or no? Yes. So just substitute the value of Li in the form of summation. So it will be summation I equal to 1 to n Ri cross Pi. Alright, where we know Ri is the position vector of the ith particle and Pi is the linear momentum of the ith particle. So to show the total angular momentum of a system of particles in the form of position vector and linear momentum, the expression is this one, 6.25b. Alright. Torque for a system of particles. So from total angular momentum, that is L. So using the total angular momentum, here we will calculate the torque for a system of particles. So we know L is the total angular momentum. So differentiate it with respect to time. So when we differentiating our total angular momentum with respect to time, we will get dl upon dt is equal to the differentiation of Li with respect to time. So d summation I equal to n Li upon dt, where we know Li is the angular momentum of ith particle. So this is very simple form. Differentiating total angular momentum with respect to time. So it gives rate of change of angular. So rate of change of total angular momentum, it will be dl upon dt is equal to summation I equal to 1 to n for nth particle. So for n particle, so it will be dli upon dt. Now we know tau is equal to what? For ith particle, torque, it will be dli upon dt. Yes or no? So just substitute the value of torque in this relation. Alright. So you will be get this form. So tau I is the torque on ith. Torque for a system of particles. Now torque on ith particle, tau I, is given by tau I is equal to Ri cross Fi. Alright. where Ri is the position vector of ith particle and Fi is the force on ith particle. Now, the important concept here is this, that is force. So here two types of force is present. First, internal force. Second, external force. So force on ith particle Fi is the vector sum of external force Fi external acting on the particle and internal force is Fi internal exerted it by the other particles of the system. Alright. So what will be the total force, total vector sum of the force? So it will be Fi is equal to vector sum of external force plus internal force. Fi external plus Fi internal. Now we will see Fi external and Fi internal. So the net torque tau on a system of particles is the summation of individual torques of each particle. So for net torque for individual particles, it will be in the form of summation tau equal to summation I equal to n, I equal to 1 to n tau I for ith particle. Now I equal to 1 to n, we know tau equal to r cross f. So it will be Ri for ith part position vector of ith particle and Fi force on ith. Alright. So now here two types of force is present, the external force and internal. Just put the value of in F. So it will be summation I equal to 1 to n Ri cross Fi external plus Fi internal. So now taking the product, so it will be summation I equal to 1 to n Ri cross Fi external, the torque due to the external force here and this torque internal. So torque I equal to n, I equal to 1 to n Ri cross F internal. So what will be the total torque? So it will be tau external plus tau internal. Okay. Where tau external is the torque due to external forces and tau internal is the torque due to internal. Alright. Here just we put the value of Fi force, that is F external or F internal. Now we will see tau external and tau internal. So relationship between torque and angular momentum. So by Newton's third law, force between any two particles of the systems are equal and opposite. So also these forces are directed along the line joining of two particles. Thus, contribution of internal forces to the total torque on the system is zero. Because by Newton's third law, force between any two particles of the system are equal and opposite. Alright. Therefore, the net torque on the system of particles is equal to 0 due to internal force, internal torque. So here the internal torque is 0. So net torque tau equal to tau external only because tau internal is 0. Alright. By net torque and total linear momentum are related by dl upon dt, rate of change of total angular momentum. It will be summation I equal to 1 to n tau I. So dl upon dt is equal to only for external force, it will be tau external. Yes or no? Alright. Thus, the time rate of the total angular momentum of a system of particles is equal to the sum of the external torque. that is the torque due to external forces. This is important point. Conservation of angular momentum. So let's see the statement first. The law of conservation of angular momentum states that if the total external torque on a system of particles is zero, then the total angular momentum of the system is conserved. It means if the net, or we can say total external force, total external torque on a system of particles is zero, so we can say the angular momentum of that system is conserved. Means it does not change before and after. So let's see an example. So if a person holds a spinning vehicle wheel and then flips the wheel, so they will rotate in the opposite direction. So this is because the total angular momentum of the person and the wheel must be conserved. So this is the example of an angular moment. All right. Mathematically, let's see the conservation of uh, angular momentum. So according to statement, if net torque on a system of particles is zero, so the angular momentum is conserved. So if net external torque tau external is zero, so dl upon dt is zero. So we can say L equal to constant. So L constant is a vector equation. So in component form, it will be Lx is equal to K1, Ly equal to K2, and Lz equal to K3. Or these are the constant. The statement that the total angular momentum is conserved means the total angular momentum along each axis is conserved, not only for a single component. Along each axis, the total angular momentum is conserved. X axis, Y axis, and Z axis. Alright. Example 6.5. So let's see. Find the torque of a force 7i cap plus 3j cap minus 5k cap about the origin. The force acts on a particle whose position vector is I cap minus j cap plus k cap. So in this question, you have to find out the torque. So please solve this question. You have some time. So here we have to find out the torque. We know the formula of torque, tau equal to R cross F. R is the position vector and F is the, let's see. So the given position vector of the particle is R equal to I cap minus J cap plus K cap. And the force acting on the particle is F is equal to 7 I cap plus 3 J cap minus 5 K cap. Alright. Now using the formula of the torque tau equal to R cross F, we will find the tau R cross F. So we know torque acting on the particle tau equal to R cross F. So here to solve this term we will use matrix form. So using the value of position vector and the force. So just put the value of position vector and force in the formula of torque. So here position vector is I cap minus J cap plus K cap cross force is 7 I cap plus 3 J cap minus 5 K cap. Now we will take the cross product. So here two vectors. First position vector, second is force. So in determinant form, so first we take position vector. So I cap, J cap, K cap. So coefficient of terms, that is for position vector it will be 1 minus J cap. With minus J cap it will be minus 1 and plus K cap. So 1. Similarly for force. So 7 I cap plus 3 J cap minus 5 K cap. For I with I cap 7, J cap 3 and K cap minus 1. Alright. So this is the determinant form. Now we will take the cross product. So first I cap. So I cap. So neglect this and the cross multiply with I cap, J cap and K cap column. So it will be minus 5 into minus 1. So 5 minus minus plus. So 5 minus 3, 3 into 1. So minus. Alright. Now minus J cap. So neglect this column and the remaining column is I cap, J cap. So cross multiply. So it will be minus 5 into 1 minus 5 minus 7 into 1. So minus 7 plus J cap, K cap. So neglect this. So the remaining column is I cap, J cap. So it will be 3 into 1, 3 and minus 7 into minus 1. So minus minus plus. So adding this I cap 5 minus 3, 2 I cap minus 5 minus 7 minus 12 and minus minus plus. So it will be plus 12 J cap plus 3 plus 7. So it will be 10. So this is the torque. Alright. So that the angular momentum of a particle moving with constant velocity remains constant throughout the motion. Please solve this question. You have a sum. Let's see the solution. So here we consider a particle of mass m at point P, and this moves with constant velocity v at time t. All right, and the angle making is, so the position vector from the origin is r. All right, and the force here, and the li- linear momentum is of the particle uh, is mass into velocity, and the angular momentum of the particle with respect to origin r cross is the position vector cross uh, mass into velocity. This is linear moment. All right, so magnitude of the angular momentum is mode of L is equal to mass into mode of V into mode of R sine. Here theta is the angle between R and V, and R sine theta is the, and direction of L perpendicular to plane of R, and so we can say it is into the page of the figure, and direction does not change with time. So thus L remains the same in the magnitude and direction, and therefore it conserves. So here the angular momentum L is remains same, does not change. So we can say it is conserved. Summary: the total angular momentum for a system of n particles will be L is equal to summation I equal to 1 to n Li is equal to summation I equal to 1 to n Ri cross Pi, where Li is the angular momentum of individual particles. Torque for a system of particles. So the torque is rate of change of total angular momentum. So we know dl upon dt is equal to tau. Because here the internal torque is 0 due to Newton's third. External torque only. Internal torque cancel out due to Newton's third. All right. Conservation of angular momentum. So according to conservation of angular momentum, if the external torque on a system of particles is 0, so in that case a dl upon dt is 0. So L equal to, so this is the uh, conservation of angular. All components of total angular momentum L are conserved or remains constant. Now we have some questions. This is homework practice. First, a system of two particles have individual angular momentum. First, L1 equal to 3 I cap, and second, L2 equal to minus 2 I cap. So these are the individual angular momentum. What is the total angular momentum of the system? So here you have to find out the total angular momentum. So here you will be use the concept of vector sum of individual angular moment of the second. A 3 kg particle moves with constant velocity v equal to 2 I cap meter per second at position r equal to 4 j cap meter. So here velocity is given and position vector is also. Find the angular momentum magnitude. You know the angular momentum formula L equal to r cross p, where p is the linear momentum, r mass into velocity. So mass is given, velocity is given. So using the mass and velocity, you will find the linear momentum, and r is also given, that is 4j. So r cross p. So it will gives the angular momentum. Okay. What is the relationship between torque and force for a single part? So in this question, you have to find out the relationship between torque and, tau equal to r cross f. R is the position vector, F is the acting force. So this is the relation. If external torque on a system is tau external, what is the dl upon dt equal to? So here you have to find out the rate of change of angular momentum is. If what happens to angular momentum when a person holding a spinning vehicle wheel flips it? So here you have to find out the correct. All right. So these 5 questions are uh, homework. Thank you for your attention.